Very good morning, students. Welcome to the SBR online classes here. So yesterday, in the two sessions, we did the exercise on the first exercise on the integration there. It is based on the definition of the integration and with the 15 formulas which I have given yesterday. Right? What was the definition of the integration there? Derivative of the function, right? F of x is a small f of x. If we consider the derivative of a capital F of x is small f of x, then this antiderivative of or else integral of we express in this elongated symbol. So we read it as antiderivative of f of x or integral of f of x is what here? Capital F of x plus c. We should mention the integral constant, right? Got it? So if derivative of capital F of x is small f of x, then this antiderivative of small f of x is what here? Capital F of x, right? Got it? How do we read antiderivative of f of x or integral of small f of x is what here? The capital F of x. Got it now? So this is the definition how we express it, right? So this is integral sign and this is integrand, right? X is the variable of integration and c is the integral constant there. Got it? So you have to remember the definition, right? So we did the first exercise problems from 7 to 22 problems on the first exercise with the help of definition and the 15 formulas. Now, still 1 to 6 problems I have to do. So those things will be doing with the help of the method of integration there, right? Little bit complex one there. So we'll be solving with the help of method of integrations, right? So why we do these things here? Because some of the functions, some of the integrands of the integral are little bit complex one, are complicated one. So what we have to do, we have to use some of the methods to simplify them. So after simplifying, it becomes what here? Easily integrable form here. So if we use these methods for the complex integrands or complex functions, right? So it becomes what here? Easily integrable format here. So when it becomes easily integrable format, we can use those 15 formulas. Again, we can apply the integration process there. Got it? So we are using these methods of integration. So now today I am going to discuss about integration by substitution method here, right? So how we substitute the particular function to it to become as easily integrable form there, right? After that, using trigonometric identities also we will be using. It is in the next exercise, third exercise there. And by the partial fraction, right? I will be explaining you about this as well as integration by parts. These are the methods we can apply for the complex integrands of the integral to become easily integrable form then. Got it? So let us discuss about integration by substitution method now. Now, the given integral, let us consider the given integral as like this, right? Let us consider the given integral as integration of f of x with respect to x. So what we have to do, this can be interchanged. This form can be transformed into by changing the variable x as t there, right? This is the integral form. Let us assume that it is a little bit complex one. So how to interchange, how to simplify this? We can simplify, we can transform into another form. How we can transfer into another form? By changing the variable, x as some other variable as t. Let us take it as t then. So by substituting what here? How we can transform into another form? By substituting x as g of t, right? X as g of t. Now we are substituting x as g of t now. What about with respect to x? This also we have to change. What do we have to change? Differentiate with respect to x for this one. After substitution, what we have to do? We have to differentiate with respect to x here. What happens? Different x with respect to x is 1. So derivative of g of x with respect to x, what happens here? G dash of t and dt by dx, the chain rule, right? You know that. So this is the function we are differentiating with respect to x. It becomes what here? G dash of t, and t is the variable. That's why we are differentiating according to the chain rule as dt by dx. Send this dx towards left side here. So 1 into dx will be dx. What happens now? G dash of t into dt. So now these things. Now to convert this integral in the another form, substitute these things here. Substitute x, right? I am changing the variable now. Here we have the variable x. Here also we have the thing. So we are changing now. We are transforming into another form. So substitute these things in this one. What happens now? Integral of f of what I have substituted x now? It has g of t. It has g of t. Now dx. What is dx now? What is dx? It is g dash of t and dt. Now previously the integral is with respect to x. Now it has become what now? With respect to t. So we have transformed what here? We have changed the independent variable x as what now? T. Why we have to change this? Because there are some function. It will be complicated one. We are simplifying, right? Simplifying this integrands or functions to form to be easily integrable one here. So that's why we are converting like this. So I'll be further 15 formulas will be getting with the help of this definition here, right? So let me find out again some other basic formulas with related to the substitution. As you already know the some 15 formulas in the last class there, right? So with the same formulas, I'll be using some of the substitution method, right? So now I'll be using the same process here. In the substitution method problems, you have to use the same process. We have to change the variable x by the taking another function there, where we have to differentiate with respect to t, and we have to change dx as dt there, right? The same process will be applying the further 15 formulas we are getting there, right? Now, just here students, in the yesterday's class, we know that what is the x raised to n formula there? What is the x raised to n? Integral of x raised to n? What we concluded there? X raised to n plus 1 by n plus 1. N should not be minus 1. Yes or no? Now you see, by the substitution method, we obtain one more formula there. How? Just here. Instead of x, if suppose we have the linear expression, right? If suppose we have the linear expression ax plus b whole raised to n with respect to x, just here. If you compare these two things, it is little bit complicated one, little bit complex, not so much complicated. It is little bit complex one. So how to integrate these things there? How to integrate all the things? So we go with the substitution method there. So what we have to do? We have to change the variable. We have to change the variable x here. This here we have x and here this dx with respect to x. We have to change the variable there. How we can change? We have to take this complex one as total t there. I took x as g of t, right? So this total thing, this total ax plus b, right? We have to substitute total ax plus this complicated one as t now, as t. Now differentiate. So why we differentiate with respect to x here? Because I am changing with as t means here again x remains there. So even though I should interchange this also x as t there. So that's why we are doing the differentiate. Differentiate with respect to x. Differentiate with respect to x. Now friends, what happens here? A constant as it is. X with respect to x is 1. B with respect to x is constant value 0. And t with respect to x becomes dt by dx. Okay. So what happens now? A into 1 A, send this one here, it becomes A on the A plus 0 is A, and send cross multiply here. A dx is equal to dt. Remember one thing, here in the left hand side, always in the left hand side, only x variable should be there, right? Variable x factors as well as x variable should be there. Remaining constant terms or the negative value, we have to send back to the right hand side. Here we are finding constant a here, so send back to the what here, right hand side. So dx will be dt by a. So why we are doing like this? Because I have to interchange x as t there. So that's why we are differentiating here. The complicated one we took it as t, right? So we differentiated and to interchange dx there. So we found dx. Whatever the constant values or the negative values, right? We have to send back to the RHS side, cross multiply to the RHS side. So if we have x factors in the LHS side, keep there as it is, right? So this is the process of doing the substitution method. Substitute these things there. Substitute these things in this one. So what happens now? What happens here? Integration of. This is what here t. This is what here t. What I substitute t raised to n, right? Dx. What we got dx now? It is dt by a. Got it? Dx is what now? dt by a. So here 1 by a is constant. Take outside the integral. 1 by a is constant. Take outside the integral. What remains? T raised to n dt. Now you see here, friends, a little bit complicated one. Whether we found easily integrable form here, whether we have simplified in the easily integrable form, yes or no? Just here, we already know this. It looks like in this way, yes or no? Whether it looks like in this way, right? Instead of x, what we have t here. So with respect to x is there, here with respect to t is there. So apply this formula. What happens now? What happens? 1 by a as it is, 1 by a as it is, t raised to n according to this formula. What happens? T raised to n plus 1 divided by n plus 1 plus c. Agreed? Plus c we have to, sorry, here I have not written plus c, you should mention it. Plus c you should mention compulsory, right? So it is plus c, right? So now, but in the question they have asked integrate with respect to x. So that's why again we are replacing t with respect to x here. So t is what now? What is t here? T is ax plus b raised to n plus 1. After making easily integral form, apply the formula. Further, you substitute t value there in the form of x. Why? In the original question, they were asked with respect to t. So answer we have to show in the form of x itself. Got it? So what happens now? Ax plus b whole raised to n plus 1 by n plus 1 plus c. Got it? So we obtain one more formula. You have to remember the formulas also. Again, this is the 16th form here. 15 I have already given. Further 15 I will be going to explain now. Right? So there are many formulas you have to remember. And all are very easy and you can judge how you can memorize the things. It is very easy the things. Now you see. We obtained one of the formula here. Make again the list of formula here. Make again the list of formula. The 16th formula now. 15 I have already given. The 16th formula. What is the 16th formula now? Integration of ax plus b whole raised to n dx is what we got there. What we got? 1 by a ax plus b raised to n plus 1 divided by n plus 1 plus c. Plus c is we have to write compulsory where n is not equal to minus 1. This is one of the formula you have to remember. Sir, how to remember all these things, sir? No, it is easy, right? Whether you know this formula, right? Whether you know this, it is a simple basic thing here. X raised to n, how do you express x raised to n plus 1 by n plus 1? Instead of x, what we have the linear form. This formula is applicable for only the linear things, right? If instead of x we have the linear expression, then only it can be applicable there. Got it? So now, just see here. It looks like x raised to n. X raised to n formula is what here? X raised to n plus 1 by n plus 1. Right? Now you see, students. What is sine 2x derivative? What is sine 2x derivative? Derivative of sine 2x You're writing it as 2 cos 2x. Agree? Agree. Here you see sin 2x is cos 2x. What is the 2x derivative? 2x derivative is 2. So you are multiplying 2 with the cos 2x there. But in the integration, what you have to do? We have to differentiate the thing and we have to keep in the denominator there. We have to keep in the denominator, right? Integration of sin x is minus cos 2x. So what is the derivative of 2x? Is 2. We have to keep in the denominator there. In the differentiation, you are multiplying it. After differentiating, you have to divide it in the same way itself. Just see here. X raised to n is what here? X raised to n plus 1 by n plus 1. What is the differentiation of ax plus b? What is the differentiation of ax plus b? A. Yes or no? What is the differentiation of ax plus b? It is a. We have to divide it. We have to divide it. So this is the way of keeping in mind the formula here. Right? It's very easy. Rest all things are also in the same process there. Rest all things are also in the same process. Got it? It is very easy to memorize the things. First, you remember the first 15 formulas there. Automatically, you will be coming to know how to memorize these things there. Got it? So, this is how this is the process of doing what is substitution method. Right? So, in this way only, we have to solve the second exercise problems. Got it? Now, for this next formula, just see here. As we know the formula, 1 by ax, what is 1 by x? What is the 1 by x? What is 1 by x, students? 1 by x is log x. Log x plus c. Yes or no? So now, if I have like this, if I have, instead of x, if we have the linear expression, right? Sorry, what if it is not having a linear expression? For if it is not having a linear expression, means some other methods we have to use them, right? So I'll be explaining the functions of the type like this here. So 1 divided by ax plus b. Instead of x, if we have ax plus b, they're a little bit complicated one. So what we have to do? Again, we have to substitute the thing here. Substitute the thing ax plus b as what here? By the substitution method, we have to do ax plus b as t. Differentiate with respect to t. By we have to interchange this also. So a into 1 plus b is 0. T is what here? dt by x. A into 1 is a. Cross multiply. A into dx is equal to dt. I told you in the left hand side there should not be constant things or negative things. We have to send back to the. We have to cross multiply to the right hand side. So what happens? Dx is equal to dt by a. Substitute all these things in this one. Substitute all these things in this one. What happens? Right? 1 divided by what we have substituted ax plus b now? It is t. Right? Now dx. What we have substituted dx and what you have? dt by a. dt by a. So 1 by a is constant. Take outside the integral. 1 by a is constant. Take outside the integral. It becomes 1 by t dt. Now here a little bit complicated one. Whether they have simplified here in the form of t, right? Whether it looks like in this formula 1 by x dx is equal to, yes or no? It looks like in this formula. Here with respect to x is there. Here we have with respect to t. So what do we have to do? So 1 by a as it is. 1 by a as it is. What is the integration of 1 by t there? Integration of 1 by t is log of mod t plus c. We have to write. After the integration process, we have to write plus c. Log integration 1 by x is log x. That's why integration 1 by t is log t. But we require the answer in the form of x. Why? Originally they have asked integrate with respect to x there. So a final answer we need in the form of x there. So again what we have to do? Replace t as the original thing here as ax plus b plus c. Got it? So one more formula we obtained here. The 17th one now, integration of 1 by ax plus b dx is what now? Or it is what? 1 by a log ax plus b. Right? Again, it is easy to memorize here. How, sir? Just here. What is the integration of 1 by x? What is the integration of 1 by x? Log x. Here also. Integration of 1 by x is there. Make sure that the denominator should be in the linear form only, right? So 1 by x. How do you express 1 by x? Log x. So now you differentiate ax plus b. What is the differentiation of ax plus b? A into 1 plus 0, that is a. So after differentiating a to x plus b, you get a. Just put down in the denominator there. Put down in the denominator. Here also, what we have done, it is in the form of x raised to n plus 1 by n plus 1. Differentiate this, x plus differentiation is a. Just put down in the denominator. 1 by a becomes. Got it? So it is easy to memorize the things. Got it? So same as the first 15 forms as there. Now, next, let us go with the next formula by the help of substitution method here. E raised to ax plus b. Right? So what is the what is the e raised to x formula? What is the e raised to x dx? E raised to x dx is e raised to x plus c. Right? You have to remember the formula. Now, what if we have the integral of like this, e raised to ax plus b, right? Now you see, if you check, it is in this format itself, but instead of x, what we have? Linear expression, right? One more function we have. E raised to x is one of the function. Again, in the variable x, we have one more function there, that is linear expression ax plus b. Little bit complicated. What we have to do? Again, we have to go with the substitution method. Same thing. It is a complicated thing. Substitute, put as it as t there. Now, after substituting it as t, what happens? Differentiate with respect to x now. A as it is, x differentiation 1, 0, dt by dx with respect to x, so I am going. So now a into 1 is a, cross multiply a dx. Do not keep negative values and constant values in the left hand side. Keep send to the right side. Why? We need dx, that's why. Got it? Substitute these things in here. What happens now? E raised to ax plus b, what I have done here? T. So dx, I have to replace it as dt by a. Dx, I have to replace it as dt by. So 1 by a is constant, keep outside there. What happens? E raised to t dt. Whether it becomes simplified way here, right? Now it is easily integrable form here. So now e raised to x differentiation e raised to x with respect to x there. Here with respect to t. What is e raised to t with respect to t? Again e raised to t plus c by the formula. Now, so I need the answer in the form of x there. So again you replace t as what here? T as ax plus b. Ax plus b. Got it? So one more formula we got now. What is the one more formula I got? 18th one. E raised to ax plus b dx is what we have? 1 by a e raised to ax plus b. So how to memorize? How to memorize? What is the e raised to x integration? E raised to x, right? E raised to differentiation of ax plus b. Differentiation of ax plus b is a, that you have to divide it. That you have to divide it. Whereas in the differentiation, what do you do? What is the e raised to 2x differentiation? Students, what is the integration of differentiation of e raised to 2x? You are writing e raised to 2x differentiation e raised to 2x. Derivative of 2x is 2. So this is the what here? Differentiation. You are multiplying this 2x and you are multiplying with what here? E raised to 2x. But in the integration, what we have to do? Integration with respect to x, what we have to do? What is the e raised to x integration? E raised to x. Differentiate this. 2x differentiation is 2. That you have to divide it. And write on the plus c. This one. Right? Differentiate the things, divide it. Right? E raised to x integration is e raised to x. Got it? So this is how we can memorize it. So then what will be the thing here? Just tell me about this one here. E raised to minus 3x. How do you express it? E raised to x integration is e raised to x. Again, e raised to x integration is e raised to x. Now differentiate this. Minus 3x differentiation is minus 3. That you have to divide it. Plus c. So how do you write? Why now? Just now I showed you like this, right? So this is in this format here. Check it out. It is in the form of ax plus b with respect to x 1 by a. So 1 divided by a is what here? Minus 3 into a raised to x plus b. Whether you got it now? Understood? Right? Next one. What is the integration of a raised to x, students? What is the integration of a raised to x? Tell me. A raised to x divided by log a, right? Log a plus c. Yes or no? This is the integration of a raised to x is a raised to x by log a. What if we have like this? Right? What if we have like this? A to the power, instead of x we have the linear expression, right? So what we have to do? Again, it is a little bit complicated one. So what we have to do? We have to consider this capital AX plus B, right? Capital AX plus B as small t here. Differentiate with respect to x. What happens now? Same thing. A x with respect to x is 1, b is constant with respect to x is 0, and p with respect to x is dt by dx. A into 1 is a, dx just cross multiply here. A into dx is equal to dt. Now I require dx replacement of dx. So send all the constants, all the negative things if we have in the left hand side, cross multiply to the RHS side, dt by capital A. So replace all these substitutions in the given integral to what here to get the form of easily integrable. So what you have to do now? A to the power ax plus b, what we took here? T, right? Dx is what now? dt by a. So what we got now? 1 by a is constant, take outside the integral. What happens? A raised to t dt. Whether it is in this format here now, easily integrable form now, right? Here it is little bit complicated. We have simplified now. So what happens? 1 by a is a raised to t in this form. What is the formula? A raised to t divided by log a, not log t, log a plus c. So we need the answer in the form of x. They have asked integration with respect to x. So again you replace t as capital Ax plus b, ax plus b divided by log a plus c. So we got one more formula. What is one more formula here? We are doing in the same procedure all these things there. This is a method of substitution. So we got one more formula here, that is a raised to x dx is a raised to ax plus b with respect to x. What we got here? 1 by a raised to ax plus b plus c. Agree? Sir, divided by log a, small a, right? So how do you remember this? How do you remember this? Same thing. A raised to x integration is a raised to x by log a, right? Same thing. A raised to x integration is a raised to x by log a. Now you see, differentiate ax plus b. What is the derivative of capital Ax plus b is a. That you have to divide in the numerator. Got it? Now you see. Let me check out like this here. What is the a raised to x integration? What is the a raised to x integration? A raised to x by log a. Same thing. A raised to 3x integration is a raised to 3x by log a plus c. You have to write. Now, just see here. It is not simple x. It's a linear expression. Just differentiate this. Differentiation of 3x is 3. That you have to divide. Right? That you have to keep in the denominator there. Right? Just write down differentiation of 3x there, linear expression in the denominator. Right? The same thing. This is the same formula for this. Got it now? Understood? So what will be this one here? A raised to 1 minus 4x. Just see carefully here. A raised to 1 minus 4x. What do we have to do now, students here? What is A raised to x integration? A raised to x. Instead of x, what we have? 1 minus 4x. Right? Plus c. Right? Now, little bit it is complicated. What is the derivative of this one here? What is 1 minus 4x derivative? 0 minus 4 into 1, that is minus 4. So this minus 4 we have to keep in the denominator. Why? I proved here this one. A to the power ax as like this. Got it now? How to do the things? right? So this is the formula if we have given in the form of like this. Understood now? Same as the previous 15 formulas. The next 15 are little bit a modified one then, right? So now this is the thing. Okay, so next. Sine. What is sin x integration? What is sin x integration, students? Sin x integration is minus cos x. Derivative of sin x is plus cos x, but integration of sin x is minus cos x plus c. Plus c, direct compulsory. Now, what if they have provided like this? Sin of ax plus b. Sin of ax plus b. So now, what we have to do? It is little bit complicated in the x. Again, we have one more linear expression there. So what we have to do? We have to substitute this one here. So we have to substitute ax plus b, small ax plus b as t, right? So again, it becomes a as it is differentiate with respect to t now. X differentiation with respect to x is 1, b is constant with respect to x is 0, dt by dx with respect to x now. So now cross multiply. A into 1 a plus dx you cross multiply. A dx dt. Send all the constant things towards the RHS side. Dx will be dt by a. Substitute in this one now. It becomes easily integrable format here. Sine. Now ax plus b, what we got? T. What we took here? T. So again dx what we got here? dt by a. So 1 by a is constant. Take outside there. So what happens? Sine t dt. Sine t dt. So now again just here. It is easily integrable format. Whether it looks like in this way here. So what is the integration of x dx? Is minus cos x. With respect to x is there. Here we have with respect to t. What happens? So integration of sin t will be minus cos t plus c. I told you wherever minus is there, put the bracket. Wherever minus answer you are getting, put the bracket there. So what happens now? Minus 1 by a cos t plus c. Got it now? So but we need the answer in the form of x. They have asked with respect to x. So again you replace t as what here? Ax plus b plus c, right? Plus c. So we got one more formula, that is integration of sin ax plus b is minus 1 by a cos ax plus b. No need to worry here, right? Just simple. You have to remember the things, right? Just here sin 2x. So what you have to do? Sin 2x, integration of sin 2x. As we know, integration of sin x is minus cos x. In the same way, what is sin 2x integration? Minus cos 2x plus c you have to write. And also, see this inner function. Inner function is 2x. What is the derivative of 2x? 2. Derivative of 2x is 2. That 2 you should keep in the denominator. Whereas in the differentiation, what you are doing, right? What is sin 2x differentiation? Cos 2x. Again, chain rule, 2x differentiation is 2. Yes or no? So sin 2x differentiation is 2 cos 2x, so people are doing that. So this 2 you are multiplying it this one here. But in the integration, we have to divide it. Got it now? And make sure that sin is minus cos in the integration, whereas in the derivative is plus cos, right? And just if I have like this, sin of 1 minus 7x. Students, what do you do? Integration of sin of 1 minus 7x. What is sin x integration? Minus cos x. Same thing. Minus cos x is what now? 1 minus 7x, right? Plus c. And what is the derivative of 1 minus 7x? What is the derivative of 1 minus 7x, students? 0 minus 7 into 1. What happens? Minus 7. This minus 7 we have to divide to this one here, right? So why, sir? Why? Because we proved just now itself by the definition, by the method of substitution. Integration of sin of ax plus b. Just see, compare with this. It is minus 1 by a. Minus 1 by a is what here? A is minus 7 into cos of x plus b plus c. Got it? Here minus minus get cancels. So totally it will be cos of 1 minus 7x plus c. Here 7. Got it? How to do the things? Right? Just remember, it is same as that one, but if you get the inner function, just differentiate. That too, inner function should be a linear expression there. Got it? Just here, friends, the rest of the things I'll be doing directly. Now you know this, how to solve these things there, right? So after differentiating, you have to keep in the denominator. I told the procedure here. Now I am going to write the further formulas directly here, right? Just here, students. So cos of ax plus b, right? Right. So what is cos x integration? What is the cos x integration, students? Cos x integration is plus sin x. Derivative of cos x is minus sin x, but integration is plus sin x. Right? Again, if we have cos of ax plus b, do the same substitution. Right? If you do the same substitution, cos x, it will be in the form of cos t then. Right? 1 by a constant if you take cos t is what now? Cos t is sin t integration, right? Sin t. So again t we have to replace it as like this, right? Again it is replace it as ax plus b. So what do we get again? 1 by a sin ax plus b. The same process we have to do for the rest all formulas here. So that's why I'm writing directly here. Got it? Just here. What is the integration of cos 2x now? As you see, what is the integration of cos x? Sin x. Integration of cos 2x is sin 2x plus c. But it is again they have given in the inner function as linear expression. What is the derivative of 2x? Derivative of 2x is 2. That you should mention in the denominator. That you have to mention in the denominator. Cos x integration is sin x, but inner function is linear expression. Differentiated. Ax plus b integration differentiation is a. That you have to write in the denominator. Got it? Right? What if we have like this? Right? 1 minus 7x. What do you have to do? What do you have to do, friends? It is what here sin 1 minus 7x plus c. What is the derivative of 1 minus 7x? Is minus 7. That we have to write in the denominator. Got it? So this is how we memorize the formula with the help of first 15 formulas there. Right? Rest all things I'll be writing directly, students. Why? Because you know the procedure now, how to do. So similarly, we obtain the formula. Secant square ax plus b dx. What is the secant square x integration? What is the secant square x integration? Secant square x integration is tan x plus c. Yes or no? Same thing. What is the secant square x integration? It is tan x, instead of x what we have? Tan ax plus b plus c. Same thing you have to write. Secant square integration is tan x. Right? Now again we have the inner function as ax plus b. What is the derivative of ax plus b? A. So that you have to divide here. That a you have to write in the denominator. So 1 by a times of ax plus b, or else tan of ax plus b whole divided by a. You can write it. Got it now? I've written directly here. With the same substitution you can do, you'll be getting same thing, right? So why I am writing all these things? You know the procedure now. That's why I am writing directly here, right? They won't ask how we got these formulas. I am telling you how we got these things there, right? They won't ask the proof of these things. Just you have to remember to solve the problems of the integration, right? So similarly, what I do, integration of cosec square x, cosec square of ax plus b. What is the integration of cosec? Integration of cosec square x, right? Anybody? What is cosec square x integration? Cosec square integration is minus cot x plus c. Agree? So similarly, cosec square of ax plus b will be minus cot of ax plus b. Right? So now, what we have in the inner function, we have ax plus b. If we take the substitution, what is the derivative of this one here? Ax plus b derivative is a. That you have to divide. That you have to write in the denominator. That a.